11.1 Permutations and Combinations. And in this section, we're going to be using our calculator a lot, so make sure you have one available to you. All right, so let me give you a situation. Say on Fridays at your school, you have 4 different meats to choose from on the lunch menu. You could have beef and chicken, fish and pork. You may also have 3 different vegetables to choose from, like broccoli, peas, and beans, and then 2 starches, like potatoes and rice. How many different combinations of meals could you make? Well, this is an example of the fundamental counting principle, which states that in the event M, if the event M can occur in M ways, M number of ways, followed by event N that can occur also in N ways, then event M followed by event N can occur in M times N ways. In other words, you would multiply your items. Okay, if there's choices of your meat is 4 of them, and you have 3 vegetables and 2 starches, what you're going to do is just multiply those things together. And you probably did this in middle school. It's one of the little things that they do in their math classes. But you would just multiply 4 times 3 times 2, which will give you a total of 24 different types of combination of meals that you could have. Okay, again, that is the fundamental counting principle. All right, another example, which I think is kind of cool. In Maryland in 2004, you could have 3 letters and 3 digits on your license plate. But in 1912, you could only have 4 digits, and repetition was okay. Now remember, there are 26 letters in the alphabet, even in 1912, and the numbers would be from 0 to 9, okay? So if you were to figure up this, there are 26 letters, and you can have 3 different letters. So you could have 26 times 26 times 26 for the 3 different letters. And there are 10 numbers, 0 counting as a number, 0 to 9. There are 10 numbers, so that would be 4 digits of numbers. So it would be 10 times 10 times 10. Let's see. 1912, you can only have 4 digits. Did I only leave? Oh, okay. 10 times 10 times 10 for the 2004. When you multiply this, 26, 26, 26, 10, 10, and 10, you get this number. It's supposed to say, I believe it says, should not have an N there. Let me fix that right now. Pretend you don't see that N. Whoa, not like that. Alright. End is, I'm trying to make the N go away. It's not working. I can't write on here. White. Should, okay, there you go. It's not there. Alright, 17,576 different choices of license plate. In 1912, though, you can only have 4 digits, and that was 10 and 10 and 10 and 10, which only made 10,000. In 1912, they didn't have as many cars as what we do now, so they didn't have to have as many choices. What is the difference between the number of possible license plates in 2004 compared to 1912? Well, you take the larger number and subtract the smaller number, and this is the difference between the 2 years. That's a lot more license plates than we had in 1912. And I dare say now, in the state of Virginia, we have 3 letters and 4 numbers after the letters, so it'd be even more. So that is a way of figuring up using the fundamental counting principle. You multiply each thing and just keep on multiplying them together. Alright, to find out how many choices that you could have. Well, in our section, we're going to be talking about mostly is something called permutation, which is an arrangement of items in a particular order, picky, very picky order, unique order. Permutations are very picky. That is the thing to remember. Permutations P, picky P, okay? For example, how many ways can you file 12 folders, one after another, in a drawer? Okay, well, you've got 12 folders, and you have, 12 choices of those folders to put in the first folder in the cabinet. Okay, so once you put that folder in, now that you have that in place, how many choices do you have left for the second folder? Well, there's now 11 left. So there's 11 choices. So we had 12. Now we have 11. All right, so then when we go to put the third one in, we only have 10 left. And it goes on and on and on and on and on and on until you finish with the place in the folders. So each time you're taking one away. Instead of writing out all the possible ways, we can use our calculator to figure this out really easy. It's called using the factorial notation. Okay, we have 12 folders, and that will be 12, and this exclamation point is really factorial in math. Okay, so 12 factorial is 12 times 11 times 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, and 1. That would make for 479,001,600 different ways of putting those file folders in the cabinet. Now, I know that you're sitting around saying, well, why do I need to know that? Well, there's going to be some times when you want to make up some choices, and you may need to do something without being that big, okay? So, yes, it's a nice thing to know. It's a good SAT kind of question that they might ask. All right, so in the calculator, you're going to type 12. Let me do that with you right now. Pull mine up. You're going to type in 12, and then you're going to type math, and you're going to scroll over here to the PRB thing, okay? Whoops, not that far. PRB. And you want number 4, which is the factorial thing, or the exclamation button. You hit 4, and there you go, and hit enter. And there you go. There's your number. Okay, so it'll do it for you. Nice little handy feature that you guys are allowed to use is this calculator. So when you read this 12 in the exclamation point, it's really read as 12 factorial. Okay, and that's if you are trying to place things in a specific order, okay, and you have a certain amount of numbers that you can do, and it does matter about the order, okay. All right, so whoa, didn't need that. Okay, so when you use that, you can use the factorial notation, or you can use this formula, okay, and on your standardized tests that you will be taking and your formative assessment, any of those things, they are going to give you this formula on your formula sheet. So you don't have to memorize it, but you don't even really need to know that. It's good as a backup in case you forget what to do, but I'm going to show you how to use your calculator to do it even faster. In case you forget, let me go over what the little pieces are. Okay, this N, let me get a different color, where we have N and then a big P and then an R. This N is for the total number of items. Again, that's what the N is. And the R is for how many at a time. Okay, how many at a time. All right, so N is for the total number, and it will always be the biggest number of the two. Now, if you only have one number in the problem that you're talking about, most likely you're going to just use that twice for the N and the R, okay? But if not, if you have one number bigger than the other, you always put the biggest number in first, okay? And again, N is the total number of items, and it will always be the biggest number. R is how many items at a time, okay? It's right here. All right, so, and then if you know what your N is, if you want to go through the whole process of doing the formula, you would type it in, use the factorial, hit enter, divide that by, and then put all your stuff in there, and then hit factorial, and then enter again, okay? I would suggest doing it in pieces if you're going to do this formula like this, but what I'm going to show you is so much easier. All right, so remember, permutations are very picky, and order matters. This is the big key, order matters. So for the file cabinet, file folder problem, you could have used this thing right here called 12P12, And that little formula there is in your calculator for you. All you have to do is plug things in. There were 12 file folders, and there were 12 number of times that they were being put in. Okay, so 12P12. In your calculator, let me bring mine back up. Hopefully it's still back on. I would type 12, and then I would go to Math, PRB for probability, and I would go to the second choice where it says NPR, push 2, and then I would push the smaller number, which still happens to be a 12 in this case, and hit enter, and there you go. Very, very, very easy. Okay, it's going to be nice because we're going to be using stuff with word problems, and you'll be able to just type it in. There you go. And just remember, when you type this in, always put the bigger number first. And if you're working, like I said, with that's if you're working with two different numbers. If you're not, and you're only given one, then you just put it in twice. Should work. Okay? We'll have time to practice these in class. Suppose, though, you want to know how many ways 10 runners can finish first, second, and third place in a race with no time. Okay? So we're going to be really picky. We're going to have 10 runners. That's going to be the total number. Okay? Total number. And we're going to have them only finish, we're only concerned with the first, second, and third places, okay? So we don't care about fourth, fifth, sixth, or whatever. We only want to know about first, second, and third. So think about it. At the beginning of the race, every runner has the opportunity for first place. But after the first place person has been decided, you only have 9 options for second place. And then after that person's been decided, then you only have 8 options for third. This is a permutation using some of the objects from the original number. So to set this up, you have 10 runners, but you have 3 places, first, second, and third. This would be a 10P3, and if you put that in your calculator, believe it or not, it'll give you the answer without doing all those calculations. Otherwise, it would be 10 times 9 times 8, which let's do that. 10 times, whoa, that is not a 10. 10 times 9 times 8 equals, ta-da, okay? But if you want to do the quick and easy way, you would do 10, math, probability, number 2, and 3. Bam. Okay? Very, very simple. Okay, so once you know what it is, you can type it in. Alright, so permutations are basically rearranging elements of a set. Duplications in different orders are fine, okay? Usually permutations tend to be very large numbers. So if you were talking about working with letters, like in my next example, we want 4 letters, A, B, C, and D, and we want to find all the combinations using only 3 of those letters. So as long as the letters are in different order, because order is what matters with permutations, it's considered a different permutation. So it doesn't matter. If we had ABC and ACB, that is a different permutation, and that's an additional one. It counts, okay? It does not matter about if it repeated and it's the same letters. It's in a different order, and that's what matters to permutation, okay? So that would be for permutation 3, I believe, if you wanted to put that in your calculator. Alright, so a selection of items that where the order does not matter, a selection of items where the order does not matter is a combination. Okay, this is the other kind. Combination. So order does not matter. So in other words, before, in a permutation, we would count A, B, C, and C, B, A as two different combinations. But with a combination, that would be the same thing. So we'd only want unique combinations where the order does not matter. It won't work if we wanted to use ABC versus CBA in a combination. kind of hard to explain this until you see the problems. All right, so in the example, in the problem with the first, second, and third place winners in the race, okay, where they were running, suppose if only the top 3 finishing the race advanced to the state finals, okay, just the top 3. This is an example of combination because it doesn't matter if you finish third or first, you still get to go to the states, okay, that's a combination. So when it doesn't matter, as far as whether you finish third, first, whatever, that's a combination. Combinations tend to be much smaller numbers because they are a subset of permutations. Okay? So in the example we had where we were talking about the 4 letters and we wanted 3 letters combinations, ABC and ACB and BAC, etc. would all be the same combination. Duplication is not fine in a combination. Whereas this would work for permutation, it does not. It's the same thing in a combination. Okay? Duplication is not good for combination. Duplication okay for permutation. Sound like a bunch of big words, but you'll understand once we start working with actual problems. All right, so when you have this, you'll have another formula for a combination that you'll be given on a formula sheet. And again, that's fine if you want to plug those in. The N and R still represent the same thing. N for the number of items and R for how many times. Okay? Or we could use this little formula like we had before with permutations, but this will be NCR. In the calculator, you're going to type the bigger number in, push math, go to the PRB, and then this will be option number 3 in your calculator. And as you can see, let's go back to math, probability, and you see right here number 3 is NCR, right? So you either use permutation with the P or a combination with the C in your calculator. Now let's talk about some examples. All right, so suppose you're picking a team of 5 people from a squad of 11, okay? Or like say you're having cheerleading tryouts and you have 50 girls trying out, but you're only picking a squad of 12. Okay, that same kind of thing. Those 5 people that you're picking from the original squad of 11 are a subgroup of the original squad. So that would be a combination. So remember, you always put the biggest number of the 2 that's in the word problem in first. So it's going to be 11C5. When you type that in, you would get 462 ways to pick a team of 5 out of 11 people. Okay? Most questions will not, and I say that will not, have the word permutation or combination in it to tell you what you should do. Be very cautious if it does, as they like to put that in there to see if you'll jump on it without really looking at the question and see what they want. Be cautious with it because you can misinterpret what the question is really asking you to do. So just note of warning, be cautious of the wording and read very carefully. What I have found to be most helpful for students is to write down a key list of words to look for that'll set you into a clue as to what to do. Okay, so I made a list of permutation versus combination words. Whenever you see something that's talking about usually first place, second place, third place, things like that, where it's very picky, that is a permutation. If they want to talk about arrangements, that's definitely permutation, possibilities. Where order matters, that is a permutation, big deal. Order matters. President, vice president, secretary, any of those that has, seniority, like general, squad leader, corporal, things like that, commander-in-chief, those things like that, where it has a regimented order, a defined order that you have to go by. If it says selections, if it's very picky, that is a permutation, remember. And number of ways to order something is another, if that's what they're asking you to do, the number of ways to order something. Order matters, okay? But with a combination, they could say the top 3 winners, like the runner problem, where you had the top 3 finishers and they went on to state. That's a combination. If they're choosing something from or choosing something from some other group, or selecting from another group, selecting a smaller group from a bigger one. Anytime we're talking about teams and groups, usually committees, where order does not matter, and there's no duplicates. Okay, so you cannot have the same person. If you were talking about the top 3 winners, they can't be, person cannot win this race and this race and then do this. They have to have no duplicates. Okay, duplicates are okay on the other one, but no duplicates on combinations. This is usually a smaller number, and this one is a much larger number. Okay? Alright, so the nice thing with these is just going through some word problems and figuring out which one's which, and then setting it up. Once you figure out what it is, the actual calculations will go very, very fast. Alright, so we will practice this in class, and if you have any questions, come see me, but I think you'll like this. It's kind of interesting. So this is just the beginning of our statistics unit, so we'll be doing more and more things with math, but we'll be talking about real life stuff. So if you have any questions, come see me, and I'll see you in class.